Okay, this question is very similar to one we just did, but it's a little easier, so it's more practice for you with rational functions. Plot this, make use of the first derivative. First of all, I want you to note that the numerator, the sign always matches x. So when x is 0, f is 0. When x is positive, f is positive. When x is negative, then f is negative, because the denominator is always positive. Okay, so that's the first thing. So the other thing you should realize when you're close to 0, then x is close to 0, but x squared is even closer to 0, and then you should realize that the function looks a lot like x. And as you go further away from x, it has this y equals 0 asymptote, right? Yeah, aren't we glad that we can actually use our variables the way we're used to now? Okay, so because the power of the denominator is higher than the power of the numerator, y equals 0 horizontal asymptote. But because the denominator is never 0, no vertical asymptote. And we need the derivative. Okay, so f prime is this guy is going to be squared, bottom, times the derivative of the top, minus top, times derivative of the bottom. So we have 1 minus x squared over this thing squared. Okay, so what's the numerator look like? It looks like 1 minus x squared, like that. So what does that do for us? Well, that means we know it has roots at plus or minus 1. We know the derivative between those two extreme values is positive, so it's increasing between its two extreme values, and that it's otherwise decreasing. Very similar to the analysis we had before. So between x is equal to -1 and x equals 1, this tells us that f is increasing here, but is decreasing outside of that region. Okay? So just keep that in mind. I'm going to just erase it to save space. It's a video, so if you want to see it, you can pause it as long as you want. Okay. I'm going to go ahead and put all this information together on a plot. So we already know f of 0 is 0. We know the critical values are x equals plus or minus 1. So f of 1 and f of -1 are interesting things we should be aware of. If we put x as 1 in, we get 1/2. F of -1 is -1/2. Alright? And we know that, let's see, f of 1 is 1/2. So it would be like here, f of -1, we'll say is -1/2. And we know that it's increasing to this point. And it looks kind of like y equals x there. Not quite. It's curvy, but it kind of looks that way. That it has an asymptote that's going to draw it down, and it's going to be decreasing everywhere except between its max and min. Did we do everything it asked for? It says plot, make use of the first derivative, label any asymptotes. Okay, fine. Y equals 0 asymptote. We don't really have to because we already set it up there. But it's nice because I'm grading it. Maybe I'll look for you to label it there. Find the y values for any local extreme. There, we did that. Which I didn't do on the practice exam answer key. Well, maybe I'll go fix that for you.